In this lesson, we are going to continue talking about getting limits. We're talking about infinite limits. So we're talking about what happens around asymptotes, right? And so if you have a visual is wonderful because if the limit is approaching the same thing, because again, that's the whole idea of a limit is what it's approaching. Is it approaching the same thing on either side like this? And if it is, then your limit's going to exist. But if it's like this one where it goes down in one direction, up in another direction, then your limit is not going to exist. So a graph is wonderful, but you can still figure it out without a graph. Right? And so we'll kind of talk about a little bit, how do we do that? How does that look? Right? And so here's the rough idea of what we got going on. In general, when we have a limit, we're going to plug in that value. I start with that and kind of just see what happens. Right? If I get a 0 in the numerator, but I get some value in the denominator, don't really care. Where limit exists, we should be good to go. Okay. And as long as it's not a piecewise function, and I know that there's some potential for a break in the graph. Right. But if you just get a value, and if it's a polynomial or it's a rational, then you're not going to have a break in the graph. It's just going to be 0, right? So 0 in the numerator is okay. All right, 0 in the denominator, not okay. So here's what you have to look at then. So if you plug in that value and you get a 0 in the denominator, but you get a number in the numerator, that means you're going to have some sort of an asymptote. If you get a 0 over 0, most likely that represents a whole. Right, but you're going to talk about getting something over 0. Okay, it doesn't matter what that something is. So I just kind of represent it as a positive number or a negative number, right? What's happening on the bottom is you're getting infinitely small, right? So as you plug in values, getting closer to this thing, and it's creating this infinitely small value on the bottom, you're taking a number and dividing it by something that's infinitely small. It actually creates a value that's infinitely large. All right, and so what you got to focus on is the signs of it then. So you may have, and it doesn't matter which side you are, but let's say you're on the left side and it's creating a negative infinitely small value. So then now you're taking a positive divided by a negative, and you're getting something in the negatives that's infinitely large. So here your limit would not exist because one is going up, one is going down, which is exactly kind of this situation right here. Right. And then your other situation is that the numerator becomes a negative, right? But the denominator might stay positive, but infinitely small. Then you're going to get still that same idea, but now you have a negative divided by positive. So you're looking at a negative infinity. And then here, if you have a negative small or a negative number of some kind divided by a negative infinitely small number, you are getting a positive. But they don't line up. So your limits are not going to exist. The individual sides exist, but overall your limit is not going to exist. All right, so how do we do that? So if you're looking at this and you're looking at 3 on the right, and then we'll look at 3 on the left. So if you're looking at values that are going to be 3, so such as, let's say you were to plug in 3.1, 3.01, 3.001. Okay, so let's kind of logic our way through this a little bit. So on the top, you're getting and plugging in 3.1, right? And then down at the bottom, you're getting something like that. So if you plug in 3.1, this is basically kind of 15, right? Because then if you did 3.01, you're just getting even closer to that value just being 15. So I'm going to treat it like it's a 15. And that's what I mean by it's just some number, right? It's not going to change. It's going to get infinitely close to 15, right? So then you're going to do 2 minus 15. But what's happening on the bottom is you're getting something about 2 minus 15, so about 13, divided by 0.1. Then when you do this one, you're getting about 13, even closer, divided by something that is now even smaller. So when you divide this, you're getting a bigger value. You're dividing by a tenth, so that become 130. This would become 1300. But you have a positive divided by positive, so this value, oh, sorry, it's negative. Squeeze that in, so it's about negative 13, about negative 13. Right, so you have a negative value divided by a positive value that's getting infinitely large. So overall, you're talking about a negative number in the numerator divided by a positive infinitely small in the denominator. So overall, that side would be approaching negative infinity. And if we do that same idea here, we're doing 3 from the right. So we're going to be talking about, or 3 from the left. We're going to be doing 2 minus 5 times, let's say 2.9. And so 2.9 divided by 2.9 minus 3. So let's not do all of it. We're looking at, again, roughly a negative 13. So 2 minus 15. So we're getting about a negative 13 divided by something that's going to be a negative infinitely small, right? And then the next one, we get closer, 2.99. So this is getting infinitely small, making this overall fraction infinitely large. So the logic to it is we're talking about a negative number on the top divided by a negative infinitely small on the bottom, which is going to create a negative divided by negative, so an infinitely large value. Okay, so let's do one more. We're going to analyze the following limit analytically. We're looking at -4 from the right. Right, so I have no idea. There's quite a lot going on. So let's see if we can simplify this a little bit and take a better peek at it. First thing I want to do is let's take a negative x out of this. Right, so if we take a negative x out, we're looking at x squared minus 5x plus 6, which then was going to factor. And then here we can take a negative x out. We're going to have x squared. We're going to take x squared, negative x squared, so that'll leave us with x plus 4. All right, so the top, we got a negative x, x minus 3, x minus 2. And then on the bottom, we have a negative. Sometimes this helps to break this up at x squared and x times x, and then x plus 4. So we cancel some of this stuff out. We got the negatives that are going to undo each other. We got an x canceling an x. We're really talking about the limit. And we haven't messed with it because that 4 is still there. We're just doing a simpler version of this. So our x approaches -4 from the right of really x minus 3, x minus 2 over x times x plus 4. All right, that's the one that we're really going to need to focus on. All right, so if we're plugging in a number, we're going -4 from the right. And -4 from the right is going to be, a little visual on that. If you're looking at -4, -3, so we're looking at a value like that. So our value that we want to plug in is a -3.9. Right, so again, these are pretty much -4s that we're plugging into these. So they're just going to be numbers. So you're going to have a negative minus a negative. So you'll have a negative. And then a negative minus a 2 is going to be another negative. So those two, I don't even care what the actual values are. I know I'm about to have an asymptote at this point anyway. And then on the bottom, we have a -3.9. Now this is the key. Okay, so that's going to be a -3.9 plus 4, which is a positive. And we're going to get infinitely close to this -4, so we're still going to be a positive. So inside here, we're talking about a positive infinitely small. Okay, so let's deal with all the signs. So those negatives are going to cancel each other. We're looking at positive number divided by a negative infinitely small. Right, so that is going to be negative, and then a number divided by something infinitely small is going to get us infinity. So there's our signs, and there's our value. All right. A visual obviously is much better, but if you're talking about a non-calculator kind of a thing and you got to work through it by hand, there is definitely a way to do it without having to graph everything. Now, could I have graphed all of this and had some x-intercepts and I'd have 2 asymptotes and then we'd have a hole here? Sure, there's potentially a lot of work that goes involved into that, but we'll do that on a different example.